Okay, this is, we're going to skip ahead and do a section that we left out of chapter 4 now that we've done a bunch of graphing. Linear inequalities in two variables. So remember that a linear inequality is an equation such as y is less than or equal to x plus 1. It's just like the linear equations we've been working with, but instead of having a equal sign, you have an inequality sign. Okay, so the graph of a linear equation is a straight line. We know that. The graph of a linear inequality is what's called a half plane. Okay, and the general idea of a half plane is that if you draw a graph on a draw a graph on a coordinate axis such as this, it splits the plane, meaning the surface where this coordinate axis is drawn, it splits that plane in half, where half of the plane's on this side and half of the plane is on that side. Okay, so a linear inequality is a half plane with a boundary that's a straight line. So in the case of the drawing I just made, the green line, this green line right here, that's called the boundary. And it says to find the equation of the boundary line, we simply replace the inequality sign with an equal sign. So, for example, in the equation I was writing before, to get the boundary line, you would do y equals x plus 1 and graph it. Okay? Now, this equation that we are thinking about up here, right here, is different than the ones we've been working on, because what this says is the y value has to be less than or equal to x plus 1, not equal to. We know that x plus 1, we know that negative 1 would be the solution here. If negative 1 that were put in here for x, then 0 would be the solution. But this says that y can be anything less than or equal to. So for example, if we put 5 into this equation, we get 5 plus 1 is 6, and that means y can be equal to 6, but it also means y could be 3, or y could be negative 8, or y could be, 0, anything such that it's less than or equal to 6. So that's sort of a new concept for us, which means there are going to be a lot of ordered pairs. So let's explore this a little bit. The first thing we want to know how to do is determine whether points are solutions of an inequality. So we do this in the same way as we did it for inequality. We take the inequality and we plug in the values. So if we're going to try 1 and 5, then we plug in 1 for x and 5 for y, and then we solve it. So we get 3 minus, 3 times 1 minus 5 is less than 5. 3 minus 5 is negative 2, and that is indeed less than 5. So 1, 5 is a solution. Now let's try 6, negative 2. In the same equation, we put 6 in here for x, minus the y, which is negative 2, and that's supposed to be less than 5. Okay, so we get 6 times 3 is 18, plus 2 is less than 5, 20 is less than 5. No, this is not a solution, because it doesn't work. Okay, now here's the thing, with inequalities, you will have many solutions, not just one, but many, as you'll see. Okay, so let's graph one of these babies. I don't think you really need to write much down here. Just watch and follow and see if it makes sense. So the problem we have is we want to graph y is greater than or equal to x. Now, if this weren't an inequality and it were a regular equality, it'd be y equals x. So if we made a table for that, we'd put in 1 for x, and we get out 1 for y. We'd put in 2 for x, we get out 2 for y. We'd put in negative 3, and we get out negative 3 for y. So the graph of y equals x looks like this line right here, where it's already drawn. When you're finding the graph of an inequality, you're just going to graph it as if it were an equality to start with in order to get the boundary line. Okay, so remember this is called the boundary line. It's the equation. Since the inequality is greater than or equal to, the line is solid. Now here's why. If I pick a point on this line, say 2, 2, it makes this equation true. If I pick a point negative 3, negative 3, it is true in the equation. In other words, negative 3 is greater than or equal to negative 3. 0 is greater than or equal to 0. 2 is greater than or equal to 0. To 2. So those all are true in our equation. Y is greater than or equal to x. They lie on the line, all these points, negative 3, negative 3, 0, 0, 2, 2. And they do work in the inequality. Okay, so this red line on here is the graph of y is greater than or equal to x. Okay, so now what? So look at these 1, 2, 3, 4, 5 black points on here. It says, note that in the graph, each ordered pair, each point on this half plane, in other words, above the y equals x line, contains a y coordinate that's greater than its x coordinate. So for example, this point right here is 2, 5. The y coordinate is bigger. This point right here is negative 4, 5. The y coordinate is bigger. This point right here is negative 4, looks like maybe negative 2.5. Okay. And the y value is bigger, right? Negative 2.5 is bigger than negative 4. So all of these points on this side of our equation are fitting in the inequality. This one's negative 2, 2. The y is bigger than the x. So all of these points are solutions to this inequality. The points on the line that we mentioned before that work, and the points not on the line that are above it. So a key point about inequality says right here, thus, if one point in a half plane is a solution, then all of the points will be. In other words, if you find one point on this side of the line that works, then you know every point on this side of the graph is going to work. As an example, if I took a point down here, say, this graph is slightly off, but 1, 2, 3, 4, that would be 4, negative 1. If I plug this into y is greater than or equal to x, it doesn't work. It would be negative 1 is greater than or equal to 4, which is not true. So this is not a solution. It's on the other side of the graph, notice. So you should be beginning to see that the graph of an inequality, a linear inequality in two variables, the boundary of that graph is going to be its linear graph with when you put an equals to in the equation, and then you're going to have all the points on one side of the line or all the points on the other side of the line, depending on which side works. Okay, so now, because we know that those points that we had graphed over here, I don't remember exactly where they were, but we had a bunch of them, right? Because we know they worked, we know that the solution set is above the line in this case. So you see the red shading? That shading indicates that every point above this line, so this shading here, which technically goes on because technically this graph goes on, right? In both directions, indicates the solutions. And this is what we mentioned earlier was called the half plane. As we read this, the complete solution set consists of the shaded half plane as well as the boundary, because as we talked about earlier, the points on this boundary do work in the equation. They make it true. So if you notice, for any point in this half plane, in this red shading over here, y will always be greater than x. For any point on the line, right, this line right here, any point is going to be y equals x. So the shaded part is where all the y's are greater than x, and the line is where all the y's are equal to x. So our solution to this linear inequality, y is greater than or equal to x, is the half plane that's above the line y equals x. Stop and digest that for a minute. Okay, so I'm going to stop there, and I'm going to do another example, but I'm going to do it on another video so this doesn't get too large. So go on to 4.4, video part 2.